Alright, here it is. I called it the Overkill. I don't know if it's a good enough name for it or not, but the reason I did that is because it has two motors on this side just for the Y-axis alone. At one point in the design, it had two motors on the Z for this side alone. Back here, it had two motors, or still has two motors for the X-axis. And then over here, we had the same setup in reverse. So all in all, it had at one point 10 stepper motors. Now, as you can see, I've removed some of the Z's because it didn't need them. So I was impressed by that. Let's see. This machine, I absolutely love it. What's the point of being alive if you don't at least try to do something remarkable? Love that quote. The machine has a little bit more than 48 by 48 inches. I mean, it can go a couple millimeters past that, and don't let those fool you. It can actually go almost an inch, half an inch or so past that as well. Just because I don't have a whole lot of space, I'm not using all of my Y, I can reach past this, but eventually I want to kind of build this thing onto a different desk clamp thingamajigger and actually have a vise over here so that I'd be able to hold some things and let it get into there. But yeah, that's the machine. I'll get another video of it in action here soon. Alright, wanted to show this. I got a little hook down here, and I have this piece that can go into there, lock into place, so I can go hands-free while I then get to the whole call it, change out the bit. Thought that was pretty clever. Here is the overall look at the Overkill machine, and in this design you can see it still has the 2Z. You know, it's using these SRB 16 rails, and the ones that I got were 1500 millimeters long each, so what's that, just under 5 feet, and two of them together with all this rail, or with all of this router and the vacuum attachment and everything like that, I'm guessing it's at least 20 pounds. But just having a single motor on each side for the Z, it works just fine. The only thing is, up here, if you're using a coupler to attach the motor to the threaded rod, you can't use one of the ones with springs in it. You have to use a rigid one. The ones with the aluminum ones that were kind of springy, they stretched every once in a while, and so you would tell the Z to go up by like half a millimeter and it wouldn't move at all. Instead, it would just stretch right there. So by switching those out to rigid, it's been working just fine. Let me talk about the motors I am using. On the actual machine itself, these ones over here, I have two motors that are rated at something like 92, 95 ounce, and then everywhere else I'm using just 84 ounce motors. I don't think I really need that much power, but I'd rather have it and not need it than need it and not have it. So let's get into a little bit of the design on this thing. That way, if you have any questions, you can take a look at it, and I will cover what I do and don't like about this machine. So it's using these belt tensioners here on the y-axis. Let's just go start with the y-axis. These belt tensioners, there's one on the front and one on the back for each axis, and oh, come on. Basically what happens is the belt comes through, loops around this little bolt, and then goes back through, and it gets pinched inside of here. You can use this to tighten it and tension it. We have a couple of little idlers under here to make sure that the belt continues on its path. The y-axis is very, very strong. I think I'm running these motors at how many amps? Like 1.1 amps, maybe 1.2. They stay cool to the touch. I mean, they get just a tiny bit warm, but not in any way, shape, or form hot. I've got a little cable mount mounted up right here, and a tape measure trick, putting the cables from this mount up to the Z mount, and that makes it so that the cables don't get tangled, twisted up in the way, and get pinched between the motor and stuff like that. The wires on this side then basically feed through this hole up over this, and then in the other video you can see there's a giant aluminum angle rod, angle aluminum that the wire just basically rolls along on. The x-axis has a very similar design. Two motors working together, a couple of bearings under there, and the belts attach. At the moment there's just basically like a bolt going down and another bolt on the opposite side on the front, and the belt just basically comes, wraps around one of those bolts, and then is zip tied to the other side, and it's just tensioned with a zip tie. Not the best or most elegant design, but it's working for now. Alright, the machine works. I'm very impressed with it. What I don't like about it though, and what I would change if I could go back and do this whole thing again, is instead of designing it to use these two being attached on the bottom like this, basically being these two rods being attached back to back, I would switch it up so that these two are parallel to each other and just attach them to a board like a 1x4 or some sort of plywood. Because what's happening is down here, this is, in real life, this bearing block is kind of loose, I guess you can say, where the bearings making contact with the rod are just a little bit loose, and so it causes this piece to be able to ratchet in this direction just a little tiny bit, and the bolts that I've got holding it into place down on the bottom, well, I've got all the holes all lined up. I'm only using this one and this one, and then this one and this one. I didn't want to use all four, because when I used all four it got a little bit tight, almost as if the printed plastic made it twist and twist a little bit, like in this direction a little bit, and so it was having a really hard time rolling on the rails. So by putting it down to just these two bolts, it held that into place, or snug enough, and it was able to roll. But then I'm still getting this kind of action going on. So to solve it for now, rather than redesign the whole dang machine, I'm going to just basically take it apart, and then right in between this seam right here, probably going to use something like a Gorilla Glue that will expand, and so it'll put permanent tension between these two parts, and that should get rid of all of the wiggle for the router bit coming down, because right now I can reach out, grab it, and wiggle it, and I don't like that. The whole point in doing this machine was so that it wouldn't have any flex, any problems. But these rods, they don't flex at all. This doesn't flex at all. The whole thing is solid as a rock, with the exception of where these bearings are on there. So who knows, a couple of years from now, when I'm ready to redo this whole project, I might end up trying it again, where I redesign it so that all of these things are just facing forward. The hard part about that would be figuring out how to do the x-axis, but who knows, maybe I can just put that out here again. Z-axis, you guys might want to see that. Alright, So this is basically the way that the Z is working. These parts are printed, and printed, and then you can see the holes kind of on the inside where the bearing rollers are attached, and then the whole thing is basically screwed together. It's got a couple of holes here on the end so that it can attach to the rail as well, and then this thing is just for cable management. For these rails, I'm not limited. The rail can be usable 200 millimeters. If you get a longer one, it can just stick right up through these holes, and in fact on the machine itself I have 200s on the left side and I have 250s on the right side, and they just stick up through these holes and I just can't use all of the full distance. Again, the machine's a little bit overkill, a little over engineered, but so that's it. Dimensionally, it should have a working movable space that the bit can get to. Somewhere around 49 inches on the X and 51, 52, maybe even 53 inches on the Y. It's pretty good. Alright, catch you later.